this will be that second part of that I was talking about with solving equations with the variables on both sides. That's why it says part 2. So here's the common core standards. The first one is that 8.EE.7 that we've been working on for a long time to solve linear equations with one variable. And this is that second part that I was talking about, that substandard A, where we're going to give examples of linear equations. Sometimes they're going to have one solution, sometimes infinite amount of solutions, and sometimes they're going to have no solution. Okay? And I'm going to show you what those things look like and how we can prove them. All right, so let's first take a look at a problem like this. All right, so this is similar to, in fact, this is the exact one that we did before. And this is an example of a solution to, or an equation that has one solution, right? If you remember, what we did here is the first thing we did is we distributed that -3, okay, and opened up those parentheses so that we could get all of our variables together on one side. So we got a -6x here, and then we did -3 times -6, and we got a +18, okay? And then we're going to add 6x to both sides, okay, so that I can have my variables only on one side, and I ended up with 10x minus 12, and that's equal to a +18. Okay, and then I added 12 to both sides, and I'm hoping this looks familiar to you. And if it didn't, then maybe the next time you need to pay a little more attention to the first video. All right, so then this is going to be 10x is equal to 30, and I'm going to divide by 10 on both sides, and I end up with that x is equal to 3. Boom. Okay, now this is an example of one solution, right? One solution works for this. When x is 3, okay? When x is 3, it makes the left side equal to the right side. Okay, that's what this is saying. In order to maintain a balance between these two sides, right? In order for this side to be equal to this side, x has to be 3. Okay, that's the whole idea here. I'm trying to say the left side and the right side need to be balanced. They need to be the same. It needs to be fair. And the only way that can happen is when x is equal to 3. Okay. So that's an example of one solution. So let's take a look at another one, okay? And when we look at something like this, okay, the first thing we're going to do again is I'm going to say, well, you know, I can't quite get it, the variables on the same side because this side is a little bit too complicated. I want to simplify this side a little bit. So let's go ahead and we're going to distribute this, okay, the 5 to both of them, okay, because it's 5 times whatever is in here. So I have 2x and 1. Both of these things together have them 5 times. Well, that's going to mean I have 10x, and then 5 times that is going to be 5, okay? And then this is going to be 10x plus 5. And I'm hoping you look at this right away and you say the left side and the right side are the same. I mean, 10x plus 5 and 10x plus 5 are the same thing. And that's true, it is. So what we're going to do though is we're going to break this down all the way like you would normally solve it to the very end here, okay? And then I'll show you sort of what this, how we can, what it means. So let's do this. We want to get rid of the 10x, right? So I'm going to subtract 10x from this side. I'm going to subtract 10x from this side, okay? And I'm going to be left with, right? Well, 10x minus 10x is 0, and so I'm going to be left with a +5 over here. And then the same thing, right? These two x's are going to cancel out, right? 10x and -10x, and I'm left with +5 here, okay? Well, I've got 5 is equal to 5, so if I want to get rid of the 5, right, I'm going to subtract a 5 from this side, I'm going to subtract a 5 from this side, and what I'm going to end up with is that 0 is equal to 0, okay? And that's sort of an awkward looking thing, right? And you might look at that and say, well, yes, 0 is equal to 0. That's true. That always happens. If you get to this point in an equation, what it means is that anything for x works, okay? What this means is that you have an infinite amount of solutions, okay? And what that means is it doesn't matter what I plug in. The left side and the right side will always be equal. So let's test it. Let's pick a number. Let's pick 1. Okay. So if I plug in, if I say let's try x equals 1. Okay, and I do 5, and I do 2 times 1 plus 1. Okay. Well, 2 times 1 is 2, plus 1 is is 3, and 3 times 5 is this is equal to 15. Okay, well then let's do the other side, right? So I have 10 times 1 plus 5. 10 times 1 is 10 plus 5, and that's 15. So both of those check out. X could be equal to 1. Well, let's try another one. Let's try what if x is equal to 2. Okay, and if I plug this in, I'm going to get 5 times, we'll do 2 times 2 plus 1. All right, and then we'll see what happens. Well, 2 times 2 is 4, and 4 plus 1 is 5, and then 5 times 5 is 25, so this is equal to 25. Okay, well then let's try the other side, right? I have 10 times 2 plus 5, and 10 times 2 is 20, and 20 plus 5 is equal to 25. And 25 and 25, those are equal. They work also, right? So x could be 1, x could be 2. If you plug in 3, you'll notice the same thing happens. If you plug in 10, the left side and the right side will be equal. It doesn't matter whatever you plug in, the left side and the right side are the same. They will be equal. So this has an infinite amount of solutions, okay? Any number that I put in for x will make the left side equal to the right side. It doesn't matter. Okay, and that's what this idea of infinite solutions. So if you get to the point where the left side and the right side are equal to each other, and if you keep solving the problem and you break it down and you bring it all the way, what you're going to end up with, if 0 is equal to 0, you're going to have an infinite amount of solutions. Okay, well then let's take a look at something when that's not true. Okay, let's take a look at another one. Okay, so we have the same idea. We have 6x plus 2, and then on the other side we have, that parentheses multiplied by 2. So let's break open the parentheses, right? And so we'll do 2 times the 3x, and we'll do 2 times 4. So 2 times 3x that's going to be 6x, and then 2 times 4 is 8, okay? And I have 6x on this side, and I have 6x on that side. Well, that's a little bit confusing because, it's the same amount, but let's just follow the steps, right? We want to eliminate the x's from one side, okay? So we'll follow our steps here, and so I've got 6x minus 6x, well that's 0, so I'm going to be left with a positive 2. And I've got another 6x minus 6x, that's 0, and I'm left with positive 8, okay? And so let's see, I want to get rid of, it doesn't really matter, let's get rid of 2, so we'll subtract 2 from this side, and I'm left with 0 is equal to, and 8 minus 2 is 6. Well, 0 cannot be equal, when does 0 equal 6? Well, that's not true. That is impossible. And so what this means is there are no solutions. That means that no matter what, any value, anything I plug in for x, it'll never work. The left side and the right side will never, ever be equal to each other. Okay? And this is sort of, you can think of it this way. If you and your friend are standing next to each other and you have the same amount of money, and your friend finds $5 and you find nothing, you don't have the same amount of money anymore, okay? Or let's say you have $20 and your brother has $15. If your mom and dad give you each the same amount of money, if they give you the same amount of money, you will never have equal amounts, right? You'll always have more than your brother. So that's the whole idea, is that they just cannot balance. There's no way for these things to balance out. So again, please come to class with any specific questions that you have on this, okay? Ideally, you would do the steps, even if you recognize, let's say here, they're like, wait a second, or even here, you get to 2 and 8, and you're like, this can't be true. You really want to try to get it at least down to the 0 and equals something else, because if 0 is equal to 0, right, then it's all solutions or infinite solutions. And then if you have 0 is equal to something other than 0, then you know that there is no solution and it's not possible. All right, we'll do some more practice with this in class, and make sure you show me your notes.